So hello guys, welcome back to the channel. Yesterday I have uploaded a video stating that is part 1 where we were solving some queries as well as codes based on pandas and SQL, right? So I have also specifically told in the description that I will be reworking on this specific question, like why this function is not working, and will come out with the best result which is possible by me, right? uh, so without wasting the time, let's begin. Also, I wanted to tell that I will not explain this code again, like why what we were doing here. If anyone wants to visit, they can please visit the part A part, where I have done the same query in SQL. Then I have converted the same query to pandas, and we were solving this part. So to just give a reminder that what were we exactly doing, like what the question was saying. So the question was saying that we were having a table called queries, out of which we need to extract certain features. Features means columns. So query name we need to extract, and then we need to create two more features. One is quality and another is our poor query percentage. Okay. So how were we doing the calculation for quality? It was query rating and by its position. So query rating divided by its position. Query rating divided by its position. And we were doing a group by with our query name. So basically the calculation was this way: 5 divided by 1. So query rating divided by its position plus query divided by position plus query divided by position, the whole divided by number of position available, right? Or you can say number of the ratings available, because here both the cases were having 3 by 3. So this was one of the thing which we were doing uh, for solving the question, first part. Second part was how were we calculating our poor query percentage? It was simple. If the rating is 3, less than 3, we will count the number, like let's say in this part, for the part dog, I am saying here rating is out of 5. Basically only in the last parameter we have rating which is below 3. So 1 divided by means count of the number, how much it is, how many present in the column which are less than 3, divided by total numbers of rating available in the column. So total rating is 5, 5, 1. So 3 ratings, and we will divide by 1 because only 1 is the figure that is less than 3. So 1 by 3, which will be approximately 0.33, so 33% approximately. So this was the question. So while we were solving this question, I have used the lambda function over here this time, because this was a bit more of calculation part. So I have used the lambda function to do a quick calculation. So everything was fine, but we can see when I submit the answer, this part was getting wrong, right? This specific part was getting wrong. Okay, so this was the expected output. This is the uh, current output which we are getting. Basically 2.5, 0.66, they have just converted, means it is in the sorting order. So it's this way, which we can do sorting later at the last. But why are we getting 50 here? Instead we should get 33.33, means 1 by 3, like 1 divided by 3. And that also we are getting for dog, which we were discussing right now. So for dog you can see one, only one value is there which is less than 3. So 1 divided by 3 should be there, but we were not getting that. We are getting 50. Why it is happening? Then when I just identify why my query is working for this part, the cat part, it was not working for the dog part. So after the error which I have calculated, I understood this part is, you can see in the cat query, means there are 3 cats over here. So you can see all the 3 ratings are 2, 3 and 4. So these are unique ratings. So when we use the unique function, for the cat column, it will give us 3. But for the dog column, it is 5, 5, 1. Means there are 2 repetitions. So it will calculate this 5 and 5 as only one number. So it will give us 2. Basically, what was happening is for the cat, it was dividing, like 2 is the smallest number present in out of 3. So 1 divided by 3, we were getting 33.33. But for the cat, it was calculating as 1 divided by 2. So we were getting 0.5, which is 50%. So again, I'm saying why we were getting 50%, because there were 5 repetition here, and which using the unique function will always give us 2 as the result. So to avoid this kind of issue, what we can do is, we know the length of the this 3 figures, right? So basically we can use a length function here, and length function is panda is this, plus length function in SQL is this, right? So in pandas we write a small len, and in SQL we write the long thing length, right? So this is the key difference in using the length function. So what I am planning is, what if I just do a length of rating, grouping them by query name. So just observe what will happen. So length of x. Why I am doing x? Because for this function, lambda function, x has taken the column rating as its key column. I just run the query and we get an error. And what's the error? Series has no okay, it's saying it's not there. Let's do this way then. X of rating dot len. Acha. Okay, so there are 2 ratings which I have already written here. So if x is less than 3, we will do the sum, and then we will do length of x. Great. So now it should work probably, I think. Yeah. So it is accepted now. You can see it is accepted now. So where is the dog thing? This part. So it is calculating as 3.33, right? So this is what I wanted to show you. What will happen if you do the unique thing, and what will happen if you do the length thing. So why I have chosen length over here, and why my answer was not coming with unique, because the figures were repeated. That is the only issue. Let's say if it was 5, 3 and 1, so definitely it would have worked over here also. For just for an example, how it worked in the cat figure. So this is what I wanted to show you. I hope this part is clear, and let's move on to the today's question also. So today we will be discussing about a key concept, as well as I will be writing the code. Okay, let me just take this part out. I was just solving this. So this is a question of monthly transaction. Okay. So in this query, what the question tells us is, first let's observe the transaction table. I'll just take this one away. Yeah. So let's observe the transaction table. So in transaction table, it's ID, country, state, amount, and transaction date. What we are expecting is month, country, transaction count, approved count, and other figures. So let's understand what is what. So in the query, each month and country, we need to find for each month and country. So this is a keyword for grouping them. First part. Second, the number of transaction is known as trans count. Okay. Their total amount is known as trans total amount. Then number of approved transaction, number of approved transaction. Approved transaction is this part, I think, probably approved count, and their total amount. So transaction with approval. So it is approved total amount. So this part. Now, what is this thing approved and all? So you can see from this table that let's say take this two column first, means these two rows first. This is for USA. So in USA you can see there is one approved and one declined, and we are just showing the approved part over here and in the count as well, right? So this is what the concept is about. First part. Second part, you can see in month. In month, we are not just extracting the trans month of from the trans date, rather we are extracting the year with the month. So this is what we have to keep in the observation also. So uh, let's solve the question then. We will firstly solving it with the SQL so that the concept will be stuck in the mind, and then we will be going ahead with our pandas. So let's do it. Select how do we extract the month and year. So first we are extracting the year because 2018 is first. So I will extract the year first. Extract extract year from trans date. Okay. Okay. Then our this part will come, that hyphen part. So I will just put a hyphen here. Okay. Or is this, let's do this way, hyphen. Then what we are doing, we are extracting month. So extract is the function which I am using over here. Extract month. Now I will do one thing. Let's see. And I will put a concatenating over here. But when you put the concatenating here, and I will tag this column as month, table name is transaction. So what will happen when you just put the concatenating over here, concat function over here? So you can see here for the double digit month which are beyond 10 and including 10, for them it is showing accurately, but for the single digit month it is just showing the one number, like one value. But in this case what we want, if the number is single, we want 0 then xyz month, whichever month it is. So this is the part I wanted to show first, like what will happen if you just do concat. So there is another function in SQL which is known as lpad. So I use a lpad over here, okay, and then I put 2, then this 0 and bracket. Just see what will happen. Done this part, you can see now. So it is padding 0 in front of the month which we are extracting, and that month is going to the value digit 2. Means if January, so 0 will be padded first, then the actual value, right? So we are getting our first column, that is month. So I just expand this a bit. Yeah. So we are getting our first column, that is month. Done. And I will be taking this way so that I can utilize some space. Now we need country because we are grouping them out. Now we need the count function. So count, what we are exactly counting, trans count. So we will be counting the amount, count amount as trans count. Basically we are calculating, counting the amount. Now if the amount is approved, then also we have to calculate them. So this is very simple. So we will use the count with case and when statement. So case when our state is approved equals to approved, then 1, then end, because we don't want to show any 0 over here, so I'm not writing else 0. Okay, and and up as approved. Done. Now we will be showing the total amount. So sum amount as total amount, and finally we will be showing the amount that are been approved. So same again here also we will do the same thing. So case when state equals to approved, then we will show amount, else nothing is there, so I'll just put the end as approved amount from transaction group by month comma our what's the next thing, our country. Let's run this thing. So it is accepted. So basically this is what you have done till now, like we all have done till now. Just another function is there, that is lpad. And now let's solve the same question in pandas. Before moving here, I will just write one key note. Function we have used, okay, this is lead code, no, so we can use hash, yeah. So function which was unique was lpad. Lpad will first drag the month slash year slash day, anything what you are dragging. Then we put a number, like we want to put it in this figure, so it is 2 for me here. And then we will print what we want at the beginning. So this is what lpad does. Also, if anyone has any query in this, please ping me. So I have just written here so that if the audio is not clear, you can ping me out whenever you are visiting the question again. Now let's move to the pandas part. Okay, so I take this away so that we will do a fresh start. So in pandas part, we are going to solve it in a similar manner, right? So while solving it in a similar manner, first we will be extracting the date over here. Date means year and month over here. So like lpad, here we do not need to do concatenating and all, nothing is required here. So I just do this way. Df equals to, okay, I need to create a column, right? So I will just take this part, month. This is my new column from transactions. The main column where we are extracting is trans date dot uh, dt is the function which we will use, and then we are using this function strf time of y month, and then we will do is return transaction. So you just see what will happen now. You can see I have created a month, this part, and you can see here 2018 and 12 is the month name. So I just put a hyphen here. See now. So this is the function strf time which we are using here to bring this part out, which is year and month. I can again play with this. If I just put the month first and year later, then it will again show me like 12 hyphen 2018. But just remember this part. If I do a capital M here, right, and run the query, see then what will happen. You can see here, it's gone, right? So I always say you pandas is something, Python is something which is always a case sensitive kind of thing. So we have to always take care of this small queries and all, right? So this part is done. Okay, now we will be doing grouping. I will also writing the steps so that you will remember what we have done. First in SQL, we have firstly extracted the month, then we have used the concat and lpad, we got our first column. Then we have taken country, then we have done one by one aggregation codes, and then we have resolved the query. Same pattern we will be doing here, but one by one we will not do here. We will directly start with that, like this way. df equals to transactions. This is my table name, right? Group by function I am using. I am using group by with two things. One is month, because month is already in my table right now, so I'm directly taking it as month, and with country. This part is done. Now aggregation I will use. Aggregation I will be using on different things. So from here I will just start taking the new column names. Trans account. So what's trans count here? Trans count was count of ID, comma, count. Why I'm counting the ID? Because it will just show me how many numbers of counts with it. Because here nothing is there with approval, right? So simply I can just do trans count. Also, if I just run this thing, just to show you reset index, just see. You can see here, right? So you can see the first part is done. Uh, I'll just expand this. Yeah, month, country, trans count. Where is our output? Yeah, month, country, and trans count. Okay, so one thing is this is in some order which we will be sorting it at the end, not an issue. This part is done. Also, if you have seen my previous videos, what were we doing is we were doing this way, right? If you remember, we were doing this way. Like let's say we have done the group by. One second. Yeah, we have done the group by. We have done some column name, given some column name. Then we have given the aggregated column name on which we want to do the operation. Then we were putting some function like count, या फिर size, or else and unique something xyz function we were just putting, and then we were doing reset index, right? And then we were getting one solution. But in this question, what specific thing I wanted to show you was there is another way of doing the aggregation function using .agg. So aggregation is the function that we are using here, and in this use what will happen is, because we need to do all the columns with some kind of aggregation, right? Either it is a case or a count or a sum. So everything we can do inside this, and that is what exactly I am showing you. So here, when I write this count this way, it is not just a string, rather it is calculating how many IDs are there. So this is the format for writing this part. Now I will move to the next column. So my next column is approved count. What is the approved count according to the question? It is saying that when, okay, so how you will be counting the approved? It is saying that when state, comma. So when state is approved, we will be saying, we will be counting that as 1. Am I correct? So what will I do is I will use a lambda function here, lambda. So people who haven't visited my previous video, they can also know how to use a lambda at a basic level uh, and a advanced level as well. Okay, so I am using a lambda function here, and now lambda, what will I do is I will take another bracket, x equals to approved, approved, approved. Then I will just sum it out. Okay, and let me just show you now what will happen. I will be running each code after once it is written. So you can say this part 111 approved count in the expected table and the current table. So 111. Now, this will become more complicated. I will not say complicated, rather, it will become a bit logical hereafter when we come to the sum part. So, this is the easy part now. Let's do the sum. Amount dot sum. Okay. So, we will be doing this way, right? So amount dot sum, done. So this will just give me another column where the sum has been amount, like the where the amount has been summed. Now my final column, that is approved total amount. So approved total amount is again coming with the state part. Now I will again use the lambda function like how I have used before. So lambda of x. Okay. So now comes the logic over here. So guys, the fact over here is this should not be state, first thing. Why? Because we are saying that when my when my state is approved, then we are showing it as actual amount, right? So approved means amount, approved means actual amount, approved means actual amount, right? We are not counting it like 1 1 1. So here it will be amount in place of state. Now how will I give that condition? So x of transactions table where state equals to approved, then just sum it out. Then right guys, so it is submitted and it is working perfectly. So let me just revisit with you on the last part what we were talking. You can see here I have written lambda x where x equals to approved. The same thing I am writing here, lambda of x where x for coming from the transaction table, and now x is equals to state and that whole x is equals to approved, then you have to submit. So why I am not using the same logic over here? This might be a question to some of you. So the point over here is in the approved count, what were we doing is if you go back to the original table, just take this table and just forget about the code and let's you talk in a logic manner. Okay. So what they are saying, what is approved count means when the state is approved, then show it 1. Otherwise, don't show it. So in this code, I was directly optimizing and working on the state column, this part, state column. But in the final part, that is the final column, approved total amount, what they are saying is if the state is approved, then just don't say it this way like 1 1 1 or 0 0 0. Rather give me the amount, the actual amount. So now I have to work on both amount and state, like how we have used in SQL, this part. Case when state equals to approved, then show me the amount. But the previous thing was case when state equals to approved, then give me 1. Because that is how we are counting and calculating, right? So this is the key difference guys, and that is why the code also have changed here. So now if you see it carefully, let me just zoom it a bit. Yeah, so if you just see it carefully, my first column in the approved count was state. So X has directly taken the value of state. So now X is nothing but this X is nothing but it is just the state. So I'm just writing state equals to approved, then sum it like how many approved are there. But in this question, now X is actually acting as amount. So I am giving a condition, give me the amount where transaction of state equals to approved, then show me the amount. That is sum the amount. That is what we were doing, and this is why the code was bit changed over here. So I hope you have understood this question. Again, if there is any issue in the query or any part of the problem, you can definitely reach in the comment section or ping me out separately. Okay, 90 is fine, right? Maybe very small. Reset. Done. So now let's move to the final part of today's discussion. And this part is probably, is it coming? No. Okay, so let me just take this part also away. Not the game part. Today I wanted to show you this part. This is also based on a unique concept. Okay, what we will be doing here now is, because now we are in the flow of pandas, so let's solve the question first in pandas so that our mind also get easy to adopt the new things, right? So this is a question from immediate food delivery is the heading of the question. So what does this question tells? If I tell you in a short manner is, we need to identify those columns where order date and customer preference delivery date, means where order date is equal to the customer's delivered date, right? One part is this. Now once we get that table, we need to identify when the minimum of the order date was equal to the customer's delivered date. Means if I tell you, first we will get the minimum date using the min function, then we will channelize it this way, that when order date equals to deliver date, then we will be taking the average out of this figure, and then we will be just multiplying with 100, right? And then we will be converting the whole thing into a data frame. That is what we are typically going to do. So first let's understand the question, because understanding the question is also quite crucial, right? Because in the interview or the assessment test and all, they just give this part and this part, probably the output part won't be there. So let's understand from this way. If the customer's preferred delivery date is same as the order date, then called it as immediate, otherwise scheduled. One part. If the preferred customer's preferred delivery date, like 2, is equals to 2, like this part you can see, then we will call it as immediate delivery, like immediate, or else it is a scheduled. One part. Next, the first order of a customer is the order with the earliest order date that customer made. It is guaranteed that customer has precisely one first order. So each and every customer are having one as their first order, means one first order they are having. We need to calculate the percentage of immediate orders in the first orders of all customers rounded up to 2 decimals, right? So we will be calculating the immediate orders from their first order, and then we will be rounding it up to 2 decimals. So let's have a look on the table. Customer ID 2, I found one where the date are same. Customer ID 3, I found another where the date are same. Okay. And customer ID 4 is the final customer whose date are same. But just have a look on customer ID 3. Is 24 the minimum or 21 the minimum? I guess 21 is the minimum, right? So here we are actually having no orders. We will not consider customer 3 itself, because his first order is on 21st, but the delivery date is not same as the order date, so this case is scheduled. And then the immediate order is happening, but we will not consider that because they are saying that immediate orders in first orders. So I hope you have understood the question. Now how we will be solving this part. I have given a small brief to you like how we can solve, but writing the code is quite different here. So This time let's solve it without using any lambda or XYZ function. Let's solve it step by step. Okay. So now first what we will do is we will be taking the minimum order date first. So I can do this way, df equals to delivery, which is my original table of order date. Okay, and I need per customer, right? So let's group it also, right? Dot group by customer ID and order date. Okay, and I will use the min function dot reset index name equals to let's name it as k for time being. Okay, and return df. I will just show you how this is looking right now. So basically one column will be made whose name is k, this column, and here we can see each and every customer with the minimum order date and just compare over here. So what is the minimum order date of one? It is first, but delivery date is not same. For second, it is 2, so the delivery date is same. For third, we have discussed it is 21 and delivery date is not same. We will not consider this. For fourth, it is ninth and the delivery date is same. We will consider that. So if you take a boolean of this, what is happening for our just this case? So for first it is false, for second it is true, for third it is false, for fourth it is true. So basically 2 divided by, you can say 4, so it's 1 by 2, which is equal to 0.5, means 50 percentage. Now let's solve the same thing using our logics. First part is done. Now what will I do is I will merge the original table with the minimum column. So let's name this as new df equals to pd dot merge is the function which I use, merge. Original column, original table is delivery column. Next table is df. I will not use any I will not give the code any kind of logic to identify which join am I thinking will be correct or not. Let's just give it this way, on column, common column, that is customer ID, and let's run how our new df is looking now. See, now you can see here, this is our new df, delivery, customer, order date, preferred date, and key, right? So what I will do is I will be filter df. I am creating another data frame, I am creating where I will be filtering those dates where order date is equals to k. So let's write this, new df where order date equals to new df of k. Okay, and let me just run this. Now I will say a good thing over here that this will not work. Let me show you why. You can see here. So what the error is saying, it's saying that you need to return a data frame. So our filter data is not a data frame here because we are not giving it in a data frame format. Rather, we are just giving the condition here. So to give it in a data frame format, I will give the whole condition in a square bracket, and I will give a new df, which is my original this data frame over here. I will just write it over here, and now you can run the query. It's taking a bit time. Okay, so all those dates where order date was equals to the minimum of the date are have come, right? Now what we will do is we will create a column filter DA of immediate orders. So this is my column I'm creating. In this column, okay, so what is the name of this new data frame? This new data frame name is filter DF, as we have created a new DF out of the old one, which was our new DF. First DF was about group by, second DF of was about merging the original table with the new with the existing DF function, that is a group by function. Then we have given that whole thing as new df. Now from the new df I have removed and I have made another table, which table name is filter df. So when I do this way, when my filter df where order date is equals to filter df of preferred date. Now just run this. You can see it is in the boolean format. So what is boolean format? Means when false, true, this words will come, that is known as the boolean format. Okay, before moving to this part, if I just tell you this thing, why not I have again used the same thing like square bracket here and have written this part. What will happen? Because I need a data frame, right? It is showing a error. Why runtime error has come? Because when we were doing the this part specifically, we have already converted our filter df into a data frame. Then how can we again convert a data frame into a data frame? It is not possible, right? It is illogical. So it is returning a runtime error. So let me just remove this. Yeah. Okay. So now this part has come, and this is the column where my operation will be executed, which is immediate orders. So let me just write speak immediate. What is the column I want? Immediate percentage. Immediate percentage will be equals to filter df of immediate orders dot mean into 100. Means I want the average, then I want to multiply it with 100 and comma 2, and I will be just rounding this round. Basically why I have written the comma 2, because it is in the round function, and I like how we used to do in the SQL, the same thing. So rounded up to 2 decimal places. So I have written the round comma 2, so 2 decimal places. Now if I just run this, it will show me an error. Let's see why. Because the error is due to this part. You need to return a data frame instead of a numpy float, right? So now we need to convert this part immediate percentage. My word is correct, right? Immediate percentage. No. Yeah, so I need to convert this immediate percentage into a data frame. Currently, this immediate percentage is in a series format, but I need to convert into a tabular table format, which is known as a data frame. So how do we convert that? Using another function that is known as pd dot data frame. So this will be my final df, which will be equals to pd dot data frame. You can see here data frame, the words D and F are capital. Also, I will use a dictionary. Dictionary is nothing but this curly brace, and in which I will write the immediate percentage, array, immediate percentage, and then this part. How do we convert this thing? Just put a square bracket and write the same immediate percentage column name and run the final query. See, it is accepted now. I just submit this. Done. Okay. Now, if I want to solve it in SQL, so SQL, actually I have already solved it. Okay. So in SQL, if you want to solve this, there are two methods. Okay. One is this, which you can see, that is known as the window function. So basically what I have done is the same thing. I have calculated the steps also here. I means I have written the steps also for anyone to understand. So basically in this, I have just calculated the customer ID, their minimum order, what we have done in the pandas, the first code. Then I have just grouped them in this window. This part is done. Then once I have created the first window, in the second window, I have used the same thing, which is known as our case and when statement, like count case when order date is equals to customer preferred date, then 1 and divided by the whole count and into 100 round up to 2 decimal. So this is the smallest part which I have used, and then this query was resolved. Okay, so you can see this query here whenever you pause the video, but I wanted to show you another way of solving this. Let me take this away. Let's solve it using a subquery, which will be interesting and easy to understand. Select customer ID, comma, minimum of order date from delivery group by customer ID. This part which we were doing inside, correct? The first code of the pandas. Now, what I want is select order date, which is equals to preferred date, and then take the average of this and then round it up to 2 decimal, but we need to also multiply it with 100. Okay, one second. As immediate percentage, right? Now I will write a from clause, from delivery, where customer ID, comma, order date in, and let's put a bracket here and here as well, and run the query. Done, guys. So see how small this query can be and how easily we have done. I didn't use any our this window function and all, but I have shown you two different methods. Window function is already here. Whenever you pause the video at, I think at 44 minutes, you can observe the same query in Windows also, like how we can do. And similarly, I have used a subquery. Choice is yours, anything you can use. But my work was to explain the methods I have done, and hopefully you have also enjoyed and learned something new. And if also you have any other query, any other issue while solving this question or while understanding the video or while going through my videos, you are always welcome to give me the comments or tell me like which part could be improved or anything else you want in the additional part, anything XYZ, anything you want. So that's all for today. This video will be probably uploaded tomorrow morning, it seems. Yeah, and I hope you have enjoyed this video, learned something better, new, some new techniques. So thankfully, tomorrow I think I may not be uploading any video. Yeah, this video is going to upload tomorrow morning, and also in the evening tomorrow I will be uploading one more video which will be based on a SQL question, and it will be a hard level question. So we will see that question as well. I think so. That question was been asked in Google or maybe Twitter. I don't remember properly. Let's see tomorrow. So hopefully you will enjoy tomorrow also. So thank you so much, guys. Please do like, share, subscribe, and always welcome to comment and ask me query wherever you want. Thank you so much, guys. Have a great day.